we have another question here, which is absolute value of x minus 5x minus 3 less than or equal to absolute value of x plus 2. So we are supposed to find the range of values of x in this situation as well. So 5x minus 3 less than or equal to x plus 2. So 5x minus x is less than or equal to 2 plus 3. So 5x minus x is 4x, less than or equal to 2 plus 3 is 5. So x is less than or equal to 5 over 4. This is one of the solutions. Let's come to the next one, which is 5x minus 3. Then we'll find the negative of this equals negative x plus 2. So 5x minus 3 equals negative x minus 2. Let's take x to the side. It becomes 5x plus x equals negative 2 plus 3. So 5x plus x is 6x. Sorry, here is less than or equal to. Sorry, I forgot the sign. So 6x is less than or equal to minus 2 plus 3, which is 1. So x is less than or equal to 1 over 6. So let's represent this on a number line and find the range of values of x for which this equation exists. So here is 5 over 4 and here's 1 over 6. 1 over 6 is less than 5 over 4. Let's assume here too is 5 over 4. So now let's take values that are less than 1 over 6. For example, 0. Let's insert 0 here. If we insert 0, we find out that absolute value of 5 times 0 minus 3 is less than or equal to absolute value of 0 plus 2. So 5 times 0 is 0. 0 minus 3 is minus 3. It's less than or equal to absolute value of 2. Absolute value of minus 3 is 3. And then less than or equal to absolute value of 2 is 2. Now this is not a true statement. 3 is not less than or equal to 2. And therefore, this region is not one of the required region. Now let's pick values between 1 over 6 and 5 over 4. So let's pick a value like 1. So let's insert 1 into the equation. Absolute value of 5 times 1 minus 3 less than or equal to absolute value of 1 plus 2. So 5 times 1 is 5 minus 3 becomes 2. Then less than or equal to 1 plus 3, 2 is 3. Absolute value of 2 is 2, less than or equal to absolute value of 3 is 3. And this is a true statement. So you can see that this region is a required region. Now let's test for values greater than 5 over 4. For example, 2. So if we put 2 in that equation, it becomes, let me do it here, 5 times 2 minus 3. So absolute value of 5 times 2 minus 3 less than or equal to absolute value of 2 plus 2. 5 times 2 is 10. 10 minus 3 is 7. So absolute value of 7 less than or equal to 2 plus 2 is 4. Absolute value of 4. Absolute value of 7 is 7 less than or equal to absolute value of 4 is 4. So you can see that 7 is not less than or equal to 4. So that is also false. And therefore, there is only one region. This is the only required region. So the solution becomes x is greater than or equal to 1 over 6, but less than or equal to 5 over 4. So let's solve this question too, which is 1 divided by absolute value of 2, x plus 2, less than or equal to 1 divided by absolute value of 2x minus 3. So let's cross multiply. You cross multiply, you find out that absolute value of 2x minus 3 is less than or equal to absolute value of x plus 2. Now, let's solve it for the values of x. So 2x minus 3 is less than or equal to x plus 2. So we take x to the side, becomes 2x minus x is less than or equal to 2 plus 3. 2x minus x is x, less than or equal to 2 plus 3 is 5. Then now, let's find the negative of this. This becomes 2x minus 2 less than or equal to minus into bracket x plus 2. So 2x minus 2 is less than or equal to minus x minus 2. So 2x plus x is less than or equal to minus 2 and then plus 2. Sorry, here is 2x minus 3. So here is 2x minus 3. And therefore here becomes 2x plus x, then minus 2 plus 3. So here becomes 3x is less than or equal to minus 2 plus 3 is 1. So dividing through by 3, we find out that x is less than or equal to 1 over 3. So let's represent this on the number line and find the range of values of x. But then you can see that the inequality is limited to this constraint. That is, the value of x cannot be minus 2 or x cannot also be 3 over 2. So let's represent this on the number line because you can see that, okay, so if we try to represent this on the number line, x should not be equal to minus 2. So minus 2. Then let's assume here 0. Then from that, we got one of the x values as 1 over 3. And then x should not also be equal to 3 over 2. So from here, we go to 3 over 2. Then x should not be equal to 5. Sorry, the other x value is 5. So from here, we come to 5. Now let's test the values and see. Let's take values less than minus 2. If you put minus 2 into this equation, sorry, let's take a value like minus 3. If you put minus 3 here, you get absolute value of 2 times minus 3 less than or equal to absolute value of minus 3 plus 2. So 2 times minus 3 is minus 6. Minus 6 minus 3 is minus 9. Less than or equal to minus 3 plus 2 is minus 1. So absolute value of minus 9 is 9. And absolute value of minus 1 is 1. But it is not true that 9 is less than 1. So the values less than 2 is not one of the solutions. Let's take values between minus 2 and then 1 over 3. So for example, 0 is a value like that. Let's take 0. So this becomes absolute value of 2 times 0 minus 3. And less than or equal to absolute value of 0 plus 2. So 0 minus 3 becomes absolute value of minus 3. Less than or equal to absolute value of 2. Absolute value of minus 3 is 3. Less than or equal to absolute value of 2 is 2. But 3 is not less than or equal to 2. And therefore, this region is not also one of the required regions. Let's test values between 1 over 3 and 3 over 2. For example, let's take 1.4. Sorry. For example, let's take 1. If we put 1 here, it becomes absolute value of 2 times 1 minus 3. Less than or equal to absolute value of 1 plus 2. 2 times 1 is 2. 2 minus 3 is minus 1. Less than or equal to 1 plus 2 is 3. Absolute value of minus 1 is 1. Less than or equal to absolute value of 3 is 3. And it is true that 1 is less than or equal to 3. And therefore, this region is one of the required regions. And let's test for the region between 3 over 2 and 5. Let's take a value like 2. Let's insert 2 into this equation. So we find out that absolute value of 2 times 2 minus 3 less than or equal to absolute value of 2 plus 2. 2 times 2 is 5. 2 times 2 is 4. 4 minus 3 is 1. So absolute value of 1 less than or equal to 2 plus 2 is 4. Absolute value of 4. So absolute value of 1 is 1 less than or equal to absolute value of 4 is 4. And it is true that 1 is less than or equal to 4. So this region is also a required region. Now let's check for values greater than 5. Let's try 6. Absolute value of, let me do it here, 2 times 6 minus 3 is less than or equal to absolute value of 6 plus 2. 2 times 6 is 12. 12 minus 3 is 9. So absolute value of 9 less than or equal to 6 plus 2 is 8. And then absolute value of 9 is 9 less than or equal to absolute value of 8 is 8. And this is not true. It means that values greater than 5 is not one of the solutions. So at the end of the day, it is just going to be 1 over 3 and then 3 over 2 in union with 3 over 2 and then 5. So this is how it's going to be like. So in terms of inequalities, then x is greater or equal to 1 over 3 but less than 3 over 2. It is less than 3 over 2 because the value of x cannot be equal to 3 over 2. So you don't need to bring less than or equal to. Or x is greater than 3 over 2 but less than 5. So this is, less than or equal to 5. Because 5 is one of the solutions. So let's solve this one. X cubed minus 4 divided by x minus 2 is less than or equal to x plus 2. Let's bring x plus 2 to the left hand side. It becomes x cubed minus 4 divided by x minus 2 and minus x plus 2 less than or equal to 0. Now, let's multiply x plus 2 by x minus 2 divided by x minus 2. So it becomes x cubed minus 4 divided by x minus 2 and minus x plus 2 times x minus 2 divided by x minus 2. Now, you see that x plus minus 2 and x minus 2 can cancel out to give us the original equation. So we've not really, in essence, done anything to that equation. But now we can find the LCM. The LCM is x minus 2. So here becomes x cubed minus 4, then minus into bracket x plus 2, then times x minus 2 less than or equal to 0. So this becomes x cubed minus 4. However, you see that this is difference of 2 squares. So minus x squared minus 4 divided by x minus 2 less than or equal to 0. So let's continue from this side. It becomes x cubed minus 4 minus x squared. Then minus 1 times minus 4 becomes plus 4 divided by x minus 2 less than or equal to 0. So minus 4 plus 4 can go out. So it becomes x cubed minus x squared divided by x minus 2 less than or equal to 0. Let's factorize x squared out. That way x minus 1 divided by x minus 2 less than or equal to 0. So this is what we get. Now you can see that the constraints are x equals 1. We also have x equals 2. Then x equals 0. These are the constraints. So let's show it on the number line and then shade the required region. So this is going to be, let's say 0 is here, and then 1 is here, and then 2 is here. Now let's take values less than 0. For example, minus 1. If you put minus 1 in this equation, you see that the numerator is going to give us a negative number, and then the denominator is also going to give us a negative number, because minus 1 becomes -2. Then -1 - 2 is -3. Negative number divided by negative number is a positive number. However, remember that we are looking for values which are 0 or less than 0. In other words, negative values. So this region is not one of the required regions. Let's check values between 0 and 1. For example, let's choose 0.5. So if we put 0.5 here, as for x squared, it will always give us a positive number. So 0.5 minus 1 is a negative number. 0.5 minus 2 is also a negative number. Negative number divided by a negative number will give us a positive number. So here was a positive number. This place too is also a positive number. So it's not one of this region is not one of the required regions. Let's take values between 1 and 2. For example, 1.5. 1.5 minus 1 will give a positive number. And 1.5 minus 2 will give a negative number. So positive number divided by a negative number is a negative number. So we see that this region is one of the required regions. Let's check values greater than 2. For example, 3. 3 minus 1 is a positive number, divided by 3 minus 2 is also a positive number. Positive number divided by a positive number will give us a positive number. So this region too is also positive. But we are only looking for regions which are 0 or less than 0. So it's only this region. And therefore, you see that x is between 1 and then 2. So x is x is greater than or equal to 1, but less than 2. That is the range of values of x that satisfy this equation. That satisfy this linear inequality. Finally, let's solve this example, which is absolute value of 2x plus 3 divided by x minus 2 less than or equal to 1. Now you can break this absolute value into absolute value of 2x plus 3 divided by absolute value of x minus 2 less than or equal to 1. So if we multiply through by x minus 2, we find out that 2x plus 3, absolute value of that is less than or equal to absolute value of x minus 2. So let's solve this. So this becomes 2x plus 3 less than or equal to x minus 2. So 2x minus x is less than or equal to minus 2 minus 3. So x is less than or equal to minus 5. Now for the second aspect, it's going to be 2x plus 3 then less than or equal to minus x minus 2. So let's distribute. It becomes 2x plus 3 less than or equal to minus x, then minus 1 times minus 2 is plus 2. So 2x plus x is less than or equal to 2 minus 3. So 3x is less than or equal to 2 minus 3 is minus 1. So x is less than or equal to minus 1. Now let's represent this on the number line and then shade the required region. However, you see that x equals to 2 is one of the constraints. Here is minus 1 over 3. So on the number line, we are going to have minus 5 here, then minus 1 over 3 here, 0 is here, and then 2 is here. So these are the constraints. Now let's pick values less than minus 5. For example, minus 6. If you put minus 6 here, so it's going to give us absolute value of 2 times minus 6 then plus 3 less than or equal to absolute value of minus 6 minus 2. 2 times 6 minus 6 is 2 times minus 6 is minus 12. Minus 12 plus 3 is minus 9 less than or equal to minus 6 minus 2 equals minus 8. So absolute value of minus 9 is 9. But 9 is not less than or equal to absolute value of minus 8 is 8. So this is not one of the required region. Let's take a value between minus 5 and minus 3. For example, minus 1. So it becomes absolute value of 2 times minus 1 plus 3 less than or equal to absolute value of minus 1 minus 2. 2 times minus 1 is minus 2 plus 3 then less than or equal to absolute value of minus 1 minus 2 is minus 3. So minus 2 plus 3 is 1 less than or equal to absolute value of minus 3 is 3. Absolute value of 1 is 1 and then 1 is less than or equal to 3. So this is a required region. It is a true region. Now let's take values greater than minus 1 over 3, for example 0. So if we insert 0 inside, it becomes 2 times 0 plus 3 less than or equal to absolute value of 0 minus 2. 2 times 0 is 0. 0 plus 3 is 3. So absolute value of 3 is less than or equal to absolute value of minus 2. Absolute value of 3 is 3. Less than or equal to absolute value of minus 2 is 2. And it is not true that 3 is less than or equal to 2. And therefore, this region is not also a required region. Now let's take values greater than 2. For example, 3. So it becomes absolute value of 2 times 3 plus 3 is less than or equal to absolute value of 3 minus 2. 2 times 3 is 6. 6 plus 3 is 9. So absolute value of 9 less than or equal to 3 minus 2 is 1. Absolute value of 9 is 9 less than or equal to absolute value of 1 is 1. 9 is not less than or equal to 1. So this region is not also a required region. So at the end of the day, there is only one required region, which is x is greater than or equal to minus 5 but less than or equal to minus 1 over 3. That is the solution for this inequality.